Welcome back to Spring Into Math 5. This is Mr. Stein here as always, and today we're jumping into finding prime factors. Okay, I'm loving prime factors. I remember this lesson that you'll maybe see next time in Spring Into Math 6. We did a lot on prime factors and and factorization and prime numbers and stuff. So we're going to jump in today on the same thing. So first we're going to talk about prime factorization using factor trees. All right, when a number is factored, it's broken down into two factors that are either prime numbers or composite numbers. Okay, so you might remember when we talked earlier when we were talking about greatest common factor and least common denominator, things like that. We're talking about multiples and multiples multiply. Well, factors factor into numbers. Factors are the numbers that go into other numbers. So prime numbers are numbers that have only two factors, one and itself. There's some cool math videos out there that talk about prime numbers, kind of funny, but the thing is that prime numbers are special. They only have two factors that go into them, one and then whatever the number is. For example, 5 is a prime number. The only thing that go into 5 is 1 and 5. Now, composite numbers are numbers that have more than two factors. Basically, these are all the rest of the numbers. There's only so many prime numbers, but composite numbers are all the numbers in between, all the numbers that the prime numbers go into. Okay, so prime factorization is the process of breaking down a number into a product of all its prime numbers. So basically, we keep factoring numbers out of it until we get to the prime numbers and we can't break them down anymore. Okay, so we're going to look at this composite number of 36. All right, so the number 36 can be factored several different ways, but let's factor it with 6 times 6. So we have 36 equals 6 times 6. So these two factors are not prime. Therefore, both factors can be factored again. All right, so 36 is equal to 6 times 6 is equal to 2 times 3 times 2 times 3. Now, 2 and 3 are both prime numbers, so there's nothing more for me to do. So one way to organize the factors is using a factor tree. Now, factor trees are going to come up a bunch. It's really the best way to do it. It keeps you organized. You know me, I love organization in math. So we have our same number, 36. So here we go. Let's break it down into a factor tree. So we have 36. Remember, we pulled out the factors 6 and 6. Now, the cool thing about factor trees, guys, is if you can get the numbers really close, it saves you work and it saves you time. But even if you couldn't, maybe you recognize, well, you know what? The 6 in the ones place is a even number, so 2 is going to go into it. You can use 2. It's just going to take more steps, but 2 would still work. So, but I'm pulling 6s out because 6 times 6 is 36. Now I'm going to divide 6 up because 6 are not prime numbers. So then what goes into a 6? Well, 2 times 3 goes into 6. So I put a 2 and a 3 and a 2 and a 3. Now, 2s and 3s are prime numbers like I just said before, so it's broken down as best it can. So it's basically saying 2 times 3 times 2 times 3 is 36. So those are the prime factorization, the prime numbers that 36 is made up of. All right, let's try another one. Connor is working on prime factorization for his math homework. He needs to find the prime numbers that, when multiplied together, produce the number 82. How can Connor complete this problem? Now, when you're looking at 82, when I was prepping for this video, I was looking at 82 thinking, what goes into it? Well, I know a 2 goes into it because a 2 is in the ones place and 2 is an even number. And I was trying to rack my brain. Does 3 go in? 4, 5, nothing. But you know what? At the end of the day, let's just break 2 out of it if you're not sure and see where we land. So I'm going to think, well, 2 goes into it. And what's half of 82? Well, I know that one is 41. And then you look at 41 and think, well, what goes into 41? Does a 2 go into it? No. Does a 3? No. 4? No. And eventually you'll go through all the options and you'll realize that nothing goes into 41 except 41 in itself. So 41 is a prime number. So 2 and 41 are the prime numbers of 82. So just because 41 is larger than 2 or 3 or 5 or what are the common ones you're going to see doesn't mean it can't be the answer. Let's look at another one. We're going to write the prime factorization of 25. So I like 25, I like 36 because I know right away that two numbers multiplied together give me 25. And I know that 5 times 5 gives me 25. So I'm going to break it down, 5 times 5. Then I look at 5. Does anything go into 5 except 1 in itself? No, because 5 is a prime number. So the prime factorization of 25 is 5 and 5. Because 5 times 5, well, it is 25. All right, let's look at another one. Let's look at 48. Now, 48 doesn't necessarily have a double that I can just say 6 and 6 or 7 and 7 or 8 and 8 or whatnot, but I can get close. Again, I could pull 2 out And I know 2 times 24 is going to give it to me, but I also know that 6 times 8 is going to give me 48. So we have 6 and 8. And then, are 6 and 8 prime numbers? No, so I'm going to need to pull out numbers again from them. So I'm going to pull it out again of the 6, so I have 2 times 3 is 6. Let me try to make that a little bit clearer for you guys. There we go. 2 times 3 is 6. Then I'm going to pull out the prime factors of 8. Well, I know that 2 times 4 gives me 8. Now, don't get lulled to sleep here. Look at your numbers, 2, 3, 2, 4. What do you notice? Hopefully you're saying, you know what? 4 is not a prime number. 2 times 2 gives me 4. So even though this factor tree looks a little different, the prime factorization of 48 is 2 times 3 times 2 times 4 times 2 times 2. Now, when you get up in grades a little bit more, there's a better way to organize it, but for now, let's just break out those prime numbers. All right, let's try one more. Let's write the prime factorization of 100. So again, I could obviously do 2 and 50, but I know from powers of 10 long ago that 10 times 10 is 100, so I'm going to pull out tens. And that's going to give me a much easier time. Then I'm just breaking down 10. So I'm going to prime them out, pull out the tree of both of them because they're going to be the same numbers. Well, what goes into 10? Well, 2 times 5 gives me 10. All right. Then I have to look. Can anything go into 2s and 5s? Not except the 1 and itself. So 2s and 5s are prime numbers. So 2 times 5 times 2 times 5 is the prime factorization of 100. All right. That's going to wrap it up for prime factorization. This is one of my favorite things. Just break it down, work on those factors. You're going to do great. See you next time.